Section 3.5 in your textbook, the hyperbola. So basically what a hyperbola is, it sort of looks like, and for lack of a better word, it looks like two parabolas. So on a hyperbola, we will have a center. A center is the same as it always is. Center will be represented by an H and a K. So our center will be H and K. Now, across or up and down, depending on what way the hyperbola is going, a certain amount of squares or spaces away from the center will be a vertex of what looks like one parabola, and going in the other direction would be the vertex of another parabola. So the distance from the center to one vertex is called A. Just like on your major axis from the center to the edge of the ellipse, the long way is the A. In this case, it's from the center out to one vertex is A. Your A is not necessarily your longest side. So from the center back to a vertex would also be A. Now, the length of this line, this is an axis, from one vertex to the other vertex is called the transverse axis. The transverse axis. And it is 2A long. So there are two asymptotes. One will be going diagonally in one direction. Let's say it ends up going like this. And one would be going diagonally in the other direction. Let's say it does this. I kind of curved it off. I shouldn't have. It is those asymptotes that tell you how wide or narrow to make the two what look like parabolas on either side. So this would come out, but it can't cross the asymptote. This would come out, but it can't cross the asymptote. Same thing on the other side. They would come out, but they wouldn't be able to cross the asymptote. Now, how much you go up to go across or down to go across is called your B. It's really kind of hard to see. To me, the easiest way to see it is from the vertex, how many squares or how many spaces do I need to go up or down to get to the asymptote? However far that is called your B. It would be the same distance, although not in my terrible drawing, but it would be the same distance down to get to your asymptote. So that would also be B. The axis to go from one asymptote straight through your vertex to the other asymptote is called the conjugate axis. Its length is 2b. The other thing we're going to talk about in terms of a hyperbola is what are the slopes of these asymptotes? How steep are they? So in this case, remember that slope is rise over run. Remember that slope is rise over run. How much do I go up and how much do I go across? Well, when the hyperbola is going in this direction, the thing that is going up is the B. The thing that is going across or running across is your A. So the slopes of the asymptotes is plus or minus, because one is going up, one is going down, is plus or minus, and in this case, again, rise, what's going up is the B, what's going across is the A. In the textbooks, they will in the textbook, they will talk about finding the equation of the asymptotes, because if it's a straight line, there's an equation for that line. It might be y is equal to 2x plus 1 or something. We are not going to find the equations of the asymptotes. The most I'm going to ask you for is the slopes of the asymptotes. So again, if the hyperbola is opening side to side, slopes of the asymptote is going to be plus or minus b over a. Now, if instead of opening that way, if let's say the center is here, that would be my h and my k, and let's say one vertex is here and one vertex is here, and my slopes are doing this. Okay, my asymptotes are doing this, and so my hyperbola this time is opening up or down. So again, the distance from the center to one vertex is a. So the distance from the center to the other vertex would also be a. This time my transverse axis is still 2a, but it's going vertically. My b would be from a vertex out to the asymptote. That's b, and from a vertex out to the asymptote, also b. So this time my conjugate is going across. It's still 2b long. What is different is the slopes of my asymptotes. So slopes of asymptotes. I'm just going to shorten it. The slopes of my asymptotes. Remember that slope is rise over run. So what is rising this time is my A, and what is going across this time is my B. So plus or minus A over B is what the slopes of my asymptotes would be. Okay. So now let's talk about standard form and general form. So I'm giving you all the theory first before we do any of the questions, because I find with a hyperbola there's a lot of theory. So if you have a hyperbola where there's your center, there's your vertex, it's opening side to side, okay? And there's your asymptotes. If it's opening that way, a hyperbola this way is going to be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Very similar to the ellipse. The difference is it's a minus instead of a plus. Notice that my transverse axis, my distance from my center to one vertex, is going across. That is my A. So the x-axis goes across, the A is going across, so they are one on top of the other. So if instead of having that, you have, let's say, your center here, and one vertex is here and it's going up, and one vertex is here and it's going down, okay? And so you've got your asymptotes going this way this time. So now my A is going up and down, and my B is going across. The difference in your standard forms, your A squared is always first. Your B squared is always second. And it makes a difference because you are subtracting. You can't just randomly switch those. What changes is that this time A is going vertically, just like your y-axis goes vertically. So y minus k squared is going to go here, and x minus h squared is going to go here. Always equal to 1. General form is the same as it always is. No different. I'm sloping down. No different. What's different again is the characteristics of the A and the B. If your A and B are both 1, you have a circle. If your A and B are different numbers but the same sign, usually positive, you have an ellipse. For a hyperbola, A and B will be different signs. So one will be positive and one will be negative. Okay? So this is a good chance to pause the video, take a break, go get some chocolate or some chips or something, because I've done all the theory for the hyperbola. So now we are going to look at 2 examples out of your textbook, just 2. We're going to look on page 157, and we're going to look at example 1. In example 1, and I'm just going to, this is not accurate in any way, okay? They give the center as 2 and 3, so let's say that's there at 2 and 3, and they have the 2 sides opening here, okay? Look at it in your textbook on page 157. You'll get a much better picture of that. Now, what they want is they want us to describe the properties of the hyperbola. We'll do that as we do it. And they want us to write the equation in standard form and then in general form. So here's what I know. I know my A is going to be going across. And so it's always A squared and B squared. But because A is going across, that means it's going to be X minus H on the top. So my H is 2 because my center is 2 and 3. So it's X minus 2 squared. And for the Y's, Y minus 3 squared is equal to 1. The bottom is A squared. So what I would do is in my textbook, I would look at from my center, how many do I go across to get to that vertex? Turns out it is 1, 2, 3 across. So my A is 3, meaning my transverse axis, if they ask me about the length of that, would be 3 that way, 3 going back, which would give me a total of 6. The denominator is 3 squared, which is 9. B, the easiest way that I can describe to find your B is from this vertex, either go up until you get to the asymptote or go down until you get to the asymptote and count what that is. So if I look in my textbook and I start at the vertex and I count down 1, 2, 3, 4, 5, 6, my B is actually 6, meaning my conjugate axis would be 6 down and 6 up, which would be a total of 12. B squared would be 6 squared, which would be 36. So I now have it in standard form. If I was going to give the slopes of the asymptotes, again, remember slope is rise over run. So it's going to be plus or minus. What is rising is my B. What is running across is my A. So plus or minus, my B is 6. My A is 3. Well, 6 divided by 3 is 2, so it'd be plus or minus 2. That would be the slopes of my asymptotes. Now, I already have it in standard form. They ask me to change that into general form. So we've done this before with the ellipse. It's no different, okay? So in the textbook, they do this, what I feel like is a more difficult way. They say I'm going to multiply this by 9 and by 36 so I can cancel out my 9s, but that means I'm doing 36 times x minus 2 squared. If there's a common denominator that is less than whatever 9 times 36 is, personally I would do that. And with 9 and 36, a common denominator would be 36. So if I multiply this by 36, I have 36 divided by 9, which would be 4. times x minus 2 squared. If I multiply this by 36, I have 36 divided by 36, which would be 1, but there's a minus there, times y minus 3 squared, and I would multiply this side by 36, giving me 36. So this would be 4. X minus 2 squared would be x squared minus 4x plus 4, minus 1 times y squared minus 6y plus 9 is equal to 36. So this would be 4x squared minus 16x plus 16. Now be careful with this minus, it's in front of this whole bracket, minus y squared plus 6x minus 9, and I'd bring the 36 over and subtract it, which would give me 4x squared minus y squared minus 16x, or sorry, this was 6y, plus 6y, and then 16 take away 9 would be 7, and 7 take away 36 would be negative 29 is equal to 0. And there I have it in general form. And so that is example number 1. Example number 2, of course, is going the opposite way. They're starting you in general form, and they're headed into standard form, and they want to know basically all about the hyperbola. They want to know the coordinates of the center, where are the vertices, and they say the equations of the asymptotes. I just want you to find the slopes of the asymptotes. So they give us 4x squared. That is a really bad squared. 4x squared minus y squared minus 16x minus 14y minus 34 is equal to 0. So I'm going to gather my x's together, 4x squared minus 16x. I'm going to gather my y's together, minus y squared minus 14y. Oh, stop. And I'm going to move the 34 over. All right. I need to complete the square with my x's, but you cannot complete the square when there's a number, a coefficient in front of your x squared. So I'm going to take the 4 out as a common factor. Now I can complete the square. So I'm going to take the 4, I'm going to divide it by 2, which is 2. I'm going to square it, which is 4. So I'm going to add 4 and subtract 4. You have completed the square after you took the 4 out, which means when you complete the square, this 4 is in front of all of it. Wicket, stop. Sorry about that. So this is a perfect square trinomial. It is x minus 2 squared. I still have this minus 4 here. So I have 4 times x minus 2 squared minus 16. So I've done the x's. Some people like to go all the way across and do everything in one line and everything in the next line. I'd rather deal this, and it's just a personal preference for me. I deal with the x's, then I start dealing with the y's. And it's just a personal preference. It has nothing to do with right or wrong. Here, a lot of people forget that there's something in front of that y squared. There's a negative, so it actually needs to come out. And it needs to come out of both the y squared and the minus 14y, making it plus 14y. Now I can complete the square. So 14 divided by 2 is 7. 7 squared is 49. So plus 49 and minus 49. And if we want, we can put that equals 34. So minus, here is my perfect square trinomial, which is y plus 7 squared. There's my crazy dog growling in the background. And minus 49, is equal to 34. So if I multiply this negative with the y plus 7, I just have minus y plus 7 squared, but a negative 49 is plus 49 is equal to 34. I'm going to take the minus 16 and I'm going to move it over here. And I'm going to take the plus 49 and I'm going to move it over here. And I have 4 times x minus 2 squared minus y plus 7 squared, and 34 plus 16 is 50, minus 49 is 1. Now, it should equal 1, but the problem is I have a 4 here. So I'm going to think of this kind of oddly. I'm going to say, what if I divide everything by 1? Now, you cannot leave a coefficient in front of the x minus h squared. You can't leave a coefficient there. So the way I think of it is I'm going to divide this by 4 so that it's gone. But if whatever I do to the top, I have to do to the bottom. So whoops, that's not what I want. So this 4, I need a much smaller circle. So this 4 is now gone. And this is really what I have for standard form. This is what I have in terms of standard form. So now we're going to answer some questions. And now I need a bigger circle to erase. So now we're going to answer some questions about that, now that I have it in standard form. I'm also going to give a quick sketch of it, just in case that is ever asked of you. I will give, and it's just a sketch. This is not in any way accurate. Please don't, other than it's approximate. All right, so whatever is first, doesn't matter whether it's bigger or smaller, whatever the first denominator is, that is my a squared. Whatever my second denominator is, that is my b squared. So my a is a half, and my b is 1. So my center is h and k, so that is 2 and negative 7. That is my center. My vertices, in other words, where is each vertex? So this is why I draw it, so that hopefully you can see it. If my center is 2, 1, 2, and negative 7, 1, 2, 3, 4, 5, 6, 7. So right about there somewhere. If that is where my center is, my A is underneath my x's, meaning my transverse axis is going to go across, and I'm going to go half a square that way and half a square that way, meaning the total length of my transverse axis is just 1 unit. If from 2 and negative 7 I go forward half a square, that brings me to 2.5 or 2.5, and the y value didn't change because I didn't go up or down at all. So there's one vertex. The other vertex from my center, I'm going to go back half a square. So 2 minus a half would be 1.5, and the y's didn't change. So there's my other vertex. So my conjugate axis is going to be going up and down. My b is 1, meaning from my vertex to get to the asymptote, I'm going to go up 1 square. And to get to the other asymptote, I would go down 1 square, meaning the total conjugate axis would be 2 units. Now I can already draw my asymptotes because I can just connect from my center through this line right here. There is 1, and from the center through that other one, that other x that I drew, there's my other one. So if this is my vertex, there's one parabola. Remember, it can't cross those asymptotes. And there's my other parabola. Remember, it can't cross those asymptotes. So the slopes of my asymptotes. Slope is rise over run. The thing that's going up is my b, and the thing that's going across is my a. So slopes of the asymptote is going to be plus or minus b over a. So my B is 1, my A is a half. Now you're never going to leave something in that form. 1 over a half is awkward. So it's really 1 divided by a half. 1 divided by a half is 2. If you don't believe me, put that in your calculator. And so the slopes of my asymptotes are really plus or minus 2 over 1, or just 2. That's the hyperbola. Yes, I realize this was long. Hopefully you went and had a snack halfway through. Okay? Talk to you again soon.